In this week's video, we talked about how the life of the universe may be shorter than we thought. We talked about aurora on Jupiter. We talked about water on Mars. We talked about water in space. And we talked about an incredible new use of the Gaia dataset. Hope you enjoyed the video. If you do, please like and subscribe, and don't forget to check out the daily shorts. JWST has given us new insights into aurora on the largest planet in the solar system. Jupiter has strong magnetic fields, and when it interacts with energetic charged particles from solar storms or Jupiter's nearby moon Io, spectacular aurora many times more powerful than those we see on Earth are the result. In particular, JWST is able to capture very fast changes in the aurora. Scientists were expecting to see the aurora vary over maybe 15 minutes or longer, but check out this video from the paper where you can see auroral activity that's changing dramatically in mere seconds. Hopefully these new insights will give us a better understanding of Jupiter's upper atmosphere and how it exchanges heat with its surroundings. The team did uncover a new puzzle though. By observing Jupiter with the Hubble Space Telescope, they were able to obtain ultraviolet observations at the same time as their JWST observations. As you can see in this movie, they were surprised to find that the brightest spots of UV emission had no corresponding bright spots in the infrared data from JWST. The team is currently working to understand how this can happen and plans follow-up observations with JWST, as well as looking at data from the Juno spacecraft that's currently studying Jupiter. ESA's JUICE mission that is on the way to Jupiter will give fresh insights, although we're going to have to wait a while since it won't arrive at Jupiter until 2031. The paper was published today in the journal Nature Communications, and there is a link down in the description. Today, bad news for the universe, as it may end much sooner than we thought. 3 scientists have been studying Hawking radiation and calculate that the universe could end much sooner than previously predicted. Hawking radiation is the result of quantum effects outside the event horizon of a black hole and some other objects like neutron stars and white dwarfs, and causes these objects to slowly evaporate. While Hawking radiation has strong theoretical underpinnings, it's not yet been observed, although there have been a few observational hints. By looking at how long it would take white dwarf stars to disappear, which are the most persistent objects in the universe, the researchers were able to come up with a lifetime for the universe. Their estimate brings the lifetime down from 10 to the 1100 years to just 10 to the 78 years. That's a 10 with 78 zeros. So whilst this is a significant reduction to the lifetime of the universe, it's probably still worth doing a grocery shopping this week. The research brought together a black hole physicist, a mathematician, and a quantum physicist, and it's super cool to see these kinds of collaborations happening across disciplines in science. The paper was published in the Journal of Cosmology and Astroparticle Physics on May the 12th. JWST just keeps cranking out the discoveries, and today the team have announced the definitive discovery of crystalline water ice in a debris disk around a star 155 light-years away. HD 181-327 is a Sun-like star, but only about 23 million years old and a bit more massive and slightly hotter than the Sun. There's a large empty gap between the star and the debris disk, which contains chunks of rock, ice, dwarf planets, comets, and various other debris left over from the formation of the star. This would be similar to our Kuiper belt when the Sun was the same age as HD 181-327. The debris disk will be an active place at this point in the star's life, with frequent collisions between the rocky and icy bodies, creating tiny particles of water ice that are the ideal size for Webb to see. As you might expect, Webb found that the highest concentration of water ice in the system is farthest from the star, where it's coldest. This first direct detection of the water ice confirms that the solar system isn't unique and other star systems also contain frozen water. Researchers can now confidently dig deeper into how this affects the way planetary systems form around other stars and how the water ice may eventually be deposited onto those planets, with the obvious thought in the backs of their minds that water is essential for all the forms of life we currently know about. Check out this beautiful galaxy. If you haven't seen this image before, can you guess which galaxy it is? If you guess that it's our own Milky Way, then you're spot on. We can't travel out of the plane of our galaxy to take a selfie like this, so what's going on? This is actually an artist's impression of our galaxy based on data from ESA's Gaia spacecraft. Among other things, Gaia spent 10 years measuring the 3-dimensional positions and brightnesses of over 1 billion stars, and with that sort of incredible data on hand, this is what you can do. This face-on view shows us that the Milky Way has more than 2 spiral arms, and the arms are less well defined than in some other galaxies. In this one, you can see the location of our Sun in the Orion arm, and the central bar of our galaxy is more inclined with respect to the Sun than we thought. In this edge-on view, you can clearly see the central bulge of the Milky Way, but what's super interesting is the way the outer reaches of the galaxy are tilted so the whole thing has a bit of an S-curve to it. Again, that's quite different to other galaxies we see. Check out this image of NGC 4565, which you can see doesn't really exhibit this S-curve. These amazing insights into our home in the universe are only possible with missions like Gaia, JWST, and all the other incredible science and research that's going on out there. We're pretty sure that in the distant past, Mars was covered in oceans of water, as you can see in this illustration from NASA. But where did all the water go? It's something we've talked about before on this channel, and new research may offer some fresh insights. NASA's InSight lander touched down on Mars in November of 2018 and deployed a heat flow probe and a seismometer onto the surface of the red planet. It spent the next 4 years recording seismic activity on Mars, and the mission has provided many valuable insights into the internal structure of the planet. Now, scientists have used the seismic data to determine that there could be significant amounts of liquid water between 5.4 and 8 kilometers below Mars' surface. So much water, in fact, that it could cover the entire surface of Mars in an ocean between 500 and 800 meters deep. When studying the data from InSight, the scientists noticed the seismic waves slow down in a layer 5.4 to 8 kilometers below the surface of Mars, and they interpret this to be porous rock that's saturated with water much like a sponge. How could this water have gone so far below the surface of the planet? Heavy bombardment by meteorites in Mars' past could have created fractures in the surface of the planet that allowed the water to seep underground, similar to aquifers here on Earth. Scientists are interested in water on Mars for a few reasons. 1, they're just curious about the history of the planet. 2, as far as we know, the water is essential for life. And 3, if there are reserves of water on Mars, it would be a very useful resource for future human explorers. Of course, how you would access this water 5.5 kilometers below the surface is a very open question, but at least the resource would be present. More super cool science done with data from a NASA mission.